Hello, welcome to video number 38, calculating the line of best fit. It's just me and you. Mr. Lewis is still out. He'll be back for the next video, but we'll be fine and we'll make it through this. Here we go. So I want to remind you of the goal of linear regression. The goal is to fit a line as close to the data points as possible. So here we have a scatter plot. And I really like this data because I got three daughters, as you know. The X data is the father's height in inches, and the Y data is the daughter's height in inches. So we're looking for an equation for the line of best fit, and we can use the equation to predict. If you give me the father's height, then we can predict the daughter's height. It's kind of unfair, man. I'm about 77 inches tall, so I'm off the graph here. But there's a lot of convenient heights here. All right, so let's see about how we can do this. But first, I want to remind you about what we mean by the best line. So in this figure here, we have the residuals drawn. Remember that the residuals are the vertical distances. The residual is the difference between the actual data value, for this point, the actual daughter's height was 62, and the predicted Y value, which is a little bit more than 61. So this is called a residual. And you can think of it as the error. It's the difference in the actual value and the predicted value. So the largest residual is kind of over here. The actual height for the father, who was 72 inches tall, was 67, and the predicted height for a father who's 72 inches tall is about is a daughter. It's about 64.5 inches. So these vertical distances is what we're trying to make as small as possible. Now, the residuals below the graph count as negative. That's because the actual value is below the predicted value. So when we do actual minus predicted to calculate the residual, they end up being negative because the predicted value is too big. Actual minus predicted is negative. The residuals above the line of best fit count as positive. These are values where the actual is greater than the predicted. So actual minus predicted is positive. Now, if we just add these up, which would seem to be a simple way to measure how good the line does, they have a tendency to cancel each other out. So, like we mentioned in the last video, the thing we do is square the residuals. And this can be pictured in the following diagram. You notice that it still has the residuals drawn, but they've turned them into squares. And the area of each square is equal to the square of the residual. So remember, the line of best fit is sometimes called the least squares line. That's because it's the line that makes these squares as small as possible. They're not going to completely go away. They'd only go away if it was a perfect line. But again, we want to make the total squared error as small as possible. And that's what our line of best fit does. So it's important to understand that. Okay, but today we want to focus on how to calculate it and some typical questions that are asked once we do have it. So here we have the same data, the father's height and the daughter's height. And this would be a good chance to make sure you can do this on your calculator. So you might want to follow along here. The first step is enter the data into list 1 and list 2. This is the same steps as calculating R. So list 1 goes, the X data goes in list 1. Y data goes in list 2, and I have it shown here on the calculator. The next thing you do is you press Stat, Calc, 8, and go to linear regression. So this is kind of old news, we've done that. And when you press Calculate, it'll give us 4 values. We've already talked about what R means. Remember, R is the correlation coefficient, and we see here that, remember, it measures the strength of a linear pattern. And we see that this is a kind of a moderate pattern. It's not terribly weak, 0.76. It's fairly strong. Like I said, moderate is probably the best way to describe it. We still have to talk about R squared. That's coming in a few days. But here we have what we're going to use today. We have A and B. A and B give the y-intercept and the slope of the line of best fit. So I'm going to go over here to write it. So the pattern is given right here in the first line, a plus bx, and we just plug in a and b. What the calculator doesn't do, which it should do, is put a hat over the y. Remember that represents an estimate. It's our estimated value for y. And it's a plus bx, so a was 34.6. And we add to that 0.413, so I'll put 0.413 times x. So a is the constant, that's the y-intercept. And b is the slope. And you can see this matches kind of what the computer program I use matches the line of best fit they came up with. They just switch the slope times x and the y-intercept. That's okay. We can switch the order of addition. I'm going to usually write it the way a calculator does, a plus bx. So there it is. Now, we're going to practice using it. So here we have the same data, the same graph with the line of best fit drawn, but now I have the equation. And usually, after that, questions aren't so bad. The first question is kind of typical. Predict the height of a daughter whose father is 72 inches tall. So we did this in the beginning. If we go to 72 inches and go over the y-axis, we see it's going to be about 64.5 inches tall. Actually, the daughter would be 64.5 inches tall. So from the graph, we get a good estimate. But let's use the equation. So that's what our equation is for making predictions. So we're going to use it. What goes into x is the height of the father. So we have 34.63 plus 0.413 times x, but x is 72 in this case. So in goes the father's height, out comes the prediction of the daughter. So 34.63 plus 0.413 times 72 gives me 64.36, actually 64.37. Okay, that's a prediction of the daughter's height. And then, again, that's what I expected from the graph, something a little bit below 64.5. That's what we got. Predict the height of a daughter who is 67 inches tall. No problem, use the equation again. Y hat equals 34.63 plus 0.413. Now stick in our value, and we'll see what the line of best fit gives us. I get 62.3. It's about 5'2". Okay, so if the dad is 5'7", we predict that the daughter will be a little bit over 5'2". Here's another typical question. Find the residual for a data point. So the data point we're going to find a residual for is this one right here. And the residual is the difference between the predicted value and the actual value. Actually in the opposite order, actual value minus predicted. So residual is actual value minus predicted. The actual value is in the table right here. For a girl who's 66 inches, or a father who's 66 inches tall, the girl will be about 60 inches tall. So that's the actual value from the data. So when I talk about actual value, I'm talking about from the data. Now, the predicted value is from the equation. So we have to calculate that. The predicted value for a father who's 66 inches tall would be 34.63 plus 0.413 times his height, 66. So this works out to be 60 minus, let me see what we get here. I come up with something terribly wrong here, so let me try again. 34.63 plus 0.413 times 66. I come up with 61.9 approximately. And if you subtract those, you get negative 1.9. Okay, that's what this value is here. This is negative 1.9. And it's negative because it's below the graph. Okay, so find the residual of a father who's 68 inches tall. Well, 68 inches, I got to find it in the data table, corresponds to that point. So residual equals the actual value minus predicted is going to be 63.5 minus. I have to calculate what's predicted for the guy who's 66 inches tall. So I'm just going to do that real quick on my calculator. I use the line of best fit. And it turns out that the predicted height is 62.7 using the equation. So 63.5 minus 62.7 gives me just 0.8, 0.8. And it's positive. Because if I look over here at 68, the actual data value is above the graph. So that's a positive residual, 0.8. Okay, so we covered several things. There's one more thing I want to talk about. How to add the line of best fit to a graph. Okay, so sometimes we come up with an equation, we have a scatter plot, we're told to add it to the graph. Well, in algebra, we really didn't talk about equations like this. In statistics, they often have decimals. They're not nice and neat. In algebra, you have an equation like y equals 5 plus 2/3 x. So you went up 2 over 3, something like that. It's not going to fly here. The way we add a line of best fit to the graph is find two data points that satisfy it. So I just pick two values of x on the x-axis, and I find the y values for the line of best fit. So I chose x equals 66. If you put that into the equation, you're going to get a value of y hat that's 61.9. Which means the point 66, 61.9 is on the line of best fit. 66, 61.9 is about right here. So that red point is on the line of best fit. I need a second point. So I just pick another value for x. I chose 72 here. Pick them a little distance apart because I think it's better for drawing a line. So x equals 72. Put it in the equation. Y hat is, let me see what y hat is. So, sorry about this. So let me see, 34.63 plus 0.413 times 72 is about 64.4. So that gives me the point 72, 64.4, which is about right here. And I can draw the line through there. In the next graph, I did that. So if you take a look here, the two red points are the values I just calculated. And again, I just picked two values of x, calculated the predicted values, and just draw the line through the 2 points. So that's how you add a line of best fit to the graph. Just generate 2 points that satisfy the equation, plot them, draw the line. Okay, so we really did talk about a lot. We talked about how to calculate the line of best fit, how to read it from a calculator and write the equation, how to make predictions, how to calculate residuals, and how to add a line to the graph. So these are big things that we're going to be doing a lot in class, and we'll get some more practice. All right, finally, it's time for the journal assignment. Thanks for hanging in there. Here we have some interesting data here. It says Nitish has installed a solar panel on the roof of his house. He measures the number of hours of daily sunshine and the resulting number of kilowatt hours of electricity generated by his solar panel. There's a math teacher at Foreman, not me, but there is a math teacher at solar panels on his roof. I should ask him about this. His results are provided in the chart below. So the x variable is the hours of sunshine, and the y variable is how much electricity was generated. So what I want you to do is find the equation of a line of best fit. Then use your equation to predict how many kilowatt hours will be generated for 3.5 hours of sunshine. So you have to put 3.5 in for x. Just use your equation. C, D, and E are about calculating the residual for a data point. I just broke it down for you. So find the actual amount of kilowatt hours generated for 5 hours of sunshine. You can find it in the table. It says, what is the predicted amount of kilowatt hours generated for 5 hours of sunshine? You use your equation to find predicted amounts. Then finally it says, calculate the residual for when there was 5 hours of sunshine. You just subtract your answer to C and D. Okay, good luck. See you next time with Mr. Lewis. Talk to you later.